Hello everyone, welcome back to our second video about using log to solve exponential equation. In the previous video, we actually used this new tool, log, to solve this kind of equation, which in some cases we actually cannot use common base method to solve it. So in this video, we are going to look for a new application problem, and we are going to use the idea of log to solve this problem. Let's work on this together. So this scenario is a biologist is modeling the population of bats on a tropical island. And he first starts observing them. They notice there are 104 bats. The biologist believes that the bat population is growing at a rate of 3% per year. So the first question, we are going to write an equation to represent the number of the population of bats changing over the years. And also the second one, we are going to solve something. So let's just write down the first one. As we know, since population is growing, so we know it's going to be exponential growth, right? So we are going to start with, since we are talking about the bat, so B of t. And remember, let's write down the side note. The growth rate, the exponential growth function is starting with initial number and then 1 plus the growth rate over time. So this is what we do for the equation, right? So now we just plug into the value into the right place. So we know initial number of the bats is 104. And over the rate is 1 plus r. This is 3%. We are going to convert it to a decimal, 0.03 over the time t. So this is as a number of the years. After t years, this is going to be the bat number of bat. You can also just combine the two as 1.03 t. Okay, so that can be simplified this way. And second, we are going to set this as using equation from the part A. We are going to determine the number of years it will take for the bat population to reach 200. And we are going to round the answer to the nearest year. Okay, so this says the number is going to reach 200. So let's write down the answer here. Equal to 200. So as notice, actually this one we are going to look for t exponents. So we are going to isolate this part. We are going to divide by 104 for two sides. Again, please pay attention to steps and how do we just deal with everything in one step in the calculator. Do not break down everything like to solve this, to find the value before you reach to the final thing here. Okay, now 1.03 is a base over some power equal to this answer. So we can just easily rewrite this as the log. So I'm going to write very clearly so you don't make the mistakes. The base is 103. 1.03 to what power is? This is going to be our answer for this. And let's put parentheses to avoid a mistake. Now let's just put in a calculator since there's no way for us to do mental math like this. So always go to log base. And also this says 1.03. This is a base, right? And then we are going to put the answer to what power equals to 200 divided by 104. And then enter. Okay, so the answer says 22.122. And also we are going to round the answer to the nearest year since there's nothing to round it up. So it's going to be 22 years. A little bit more than, just a little bit more than 22. So it's going to be around about 22 years it will reach to 200. So this is what I mentioned before. Sometimes in reality is we need to find out reach to a certain goal, certain amount. but we need to know how long, how many years, how much the time we are going to spend to reach that goal. So this is a situation the log will come to the place to solve the problem. Thank you everyone for watching this video and study this topic with me, and I hope this is helpful and give you a new perspective regarding how to use log to solve exponential equation. See you soon everyone. Take care.